Good morning everyone. Today we are going to discuss about the properties of magnetic field lines. Now we can discuss firstly what are magnetic field lines. If we will take a cardboard and we will place a white paper over there, and on that we will place a bar magnet, and after that we will just spread some iron filings, and after that we will tap it. We will get a formation, means such type of a formation will be formed here, and these are just symbol, these are just represent some lines, and these lines are known as magnetic field lines. So in this magnetic field line some properties we just found. So what are these properties and how we can just understand these properties, we will discuss now. If we will, these are the actual form we got. If we will draw these lines on the paper, we will draw in such a way like we can understand with these lines. The property number one, we can understand the magnetic field lines is directed from north side and ending on south side, means it started from north and ending on south point. Now if this is the situation when we are considering a single bar magnet, a bar magnet is there, magnetic field lines, when we place the compass over there earlier, when we did this format, and in such way we used a compass here, we will be able to get that one line is starting from north side and ending on south point. So with the help of this formation we are able to draw, and we can identify here as the property, that first property of magnetic field lines, that the magnetic field lines is directed from north pole to south pole. We just represented this by the arrow. And in another scenario they have shown, if two uh, unlike poles will just keep nearby, so this type of formation will take place, means we can say they will attract each other, and if like poles will come nearer, they will start repulsion will take place. So first property of the magnetic field lines are, magnetic field lines is directed from north and to the south pole. Now second property, that magnetic field lines is a closed and continuous curve. Closed and continuous curve means a line will start from north pole and end will south pole. Doesn't mean it will start but it will not end anywhere. It is a closed curve, means a curve has to be complete. And continuous also means, doesn't mean, it can be a large one also, but it will ultimately complete. So two properties, started from north and ending on south, or we can say directed from north pole to south pole. Second property, we can say magnetic field lines is a closed and continuous curve. Now we will go to the third point, where we can say that magnetic field lines never intersect each other. Now the question arises, never intersect means the direction of the magnetic field lines we can find on a particular place. Whenever a particular point we want to know the direction, we can say a tangent will be drawn here. Whenever a tangent will draw, whatever the direction of the tangent will be there, the same direction will be there for the magnetic field lines. But in the other case, whenever we are considering this case, means two lines are just intersecting each other on a particular point, how we can say two tangents will be taken place, means one point one tangent will only come. If is it possible that 1.2 tangent will be there? Not possible. So if two tangent will not there, then how the direction of two magnetic field lines will be decided? So that is why this is impossible to just find two magnetic field lines on a particular place. So that is why we can say that magnetic field lines never intersect each other, because two directions on a particular point, it is impossible to get, because two tangent can't take place. So this is one property. Now another property number 4, that magnetic field lines are crowded. You will find a crowded magnetic field lines are crowded near the pole. So reason because on the pole that magnetic field is strong, means magnetic field is strong, means magnetic properties are taking place. Now in another one we can say, if magnetic field is weak on the center of the magnet. Whenever we will consider on the middle of the magnet, you will get hardly some lines are there. That is why magnetic field is weaker comparatively on the center and stronger on the pole, because of the intensity of magnetic field lines is higher, or we can say magnetic field lines are crowded near the pole. One more thing which we can discuss, like here, that in case when magnetic field lines parallel or equidistant, here in the middle you can find magnetic field lines are parallel also and equidistant also. Like we can understand in such scenario, like magnetic field lines are parallel and equidistant. So in such situations, this point is represented uniform magnetic field. What it is represented? Uniform magnetic field. So these are the properties of magnetic field lines. Thank you very much.